Hi everybody, this is Mr. Yeoman, and today we're going to continue taking a look at cladograms. In this case, we're going to take a look at a slightly more advanced cladogram. So if you need a little bit more of a review, there are some additional resources I have on Canvas, as well as some other videos that kind of walk through how to do some simpler cladograms. So I wanted to at least go through one that was a little bit more difficult, just to make sure that you understood what the concept was. And so what we have here is a list of characters. So we have 8 different organisms and multiple characters that we are looking at. And so each X here indicates that that organism has that particular character. So looking at it in this particular set of organisms, the outgroup, the organism that we're essentially comparing to that is the most different from everybody else is the sponge, since it only has a single character that it has in common with everybody else. Okay, so looking at that, we're going to start our cladogram by having our line. You don't have to write your line first. That's just how I tend to do it. But I'm going to place the sponge as our first organism in the place of the outgroup, showing that the sponge has the least in common with all of the other organisms. Okay, as we are going through and we're taking a look at that, I need to look at our characters and determine which organism has the next least number of things in common. So when I take a look at this, the jellyfish is the next organism that only has 2 characters in common. So it has cells with flagella, but it also has general symmetry. Okay, so that means I'm going to add the jellyfish in, and so our character is listed between the sponge and the jellyfish, indicating the sponge does not have symmetry, but the jellyfish does. And so I'll just continue this on. And so for these first few, it makes it really easy because they're really in order, because you can see like each one keeps losing one, but we'll get into some more advanced ones here in a minute. The next one we have is the flatworm has 3 items in common. And so when I look at that, the other item that has in common is bilateral symmetry. So that is logically the next one that is going to come onto our cladogram. So now that we're starting to move on, it's going to get a little bit more complicated because each of the following individuals have 1, 2, 3, 4, at least 4 different things in common. However, there are some differences in which ones they are. And so the one that is easiest to take a look at is that all of these have the mesoderm. So everything after this has a mesoderm. But now we start getting into some things where when I look at this, the head develops first, and that's true for earthworms, snails, and fruit flies, but it is not true for starfish and humans. And so for that reason, I'm not going to be able to place my character along that bottom line. So I'm going to take those 3, the earthworm, the snail, and the fruit fly, and so they are going to go on kind of their own branch here. And so you see how I place the head develops first up and above, so that means that everything after that, the fruit fly, the earthworm, and the snail, all have their head developing first as they are growing. But more than that, as we start taking a look at that, at some of the other characters, so earthworms have a segmented body, but snails don't. And fruit flies also have a segmented body. And so that could be another one that I can include. The snail also has a calcified shell. So that is different. So it has a calcified shell, and it's the only one that has that. So I can put that right on the line for the snail so that only the snail has a calcified shell. Going back to that, the fruit fly and the earthworm have a segmented body. But there are still some additional differences. So when we take a look at the earthworm versus the fruit fly, they both have the segmented bodies, but in addition to a segmented body, a fruit fly has a chitinous exoskeleton. Now I'm going to pause here for a second. That some of you might be looking through that and like, I don't know what all of these words mean. I don't know what a chitinous exoskeleton is. Well, hopefully you can figure some of these things out, like We've talked about chitin. We know that chitin is one of the types of molecules, one of those polymers that ends up getting made, and an exoskeleton means that outer skeleton as opposed to an endoskeleton like what we have. So it's a skeleton on the outside. So it's an outside skeleton made of chitin. Now, even if you don't know what that means, then that's okay, because that's not the goal here. The goal is to say, here are things that organisms have in common, and then we can infer an evolutionary relationship from that by saying, oh, they have all of these in common. If they have all of these things in common, that would suggest that they share a common ancestor. Every organism that has those same structures would likely share a common ancestor. Is it guaranteed? No, but at least puts us on the right track. Okay, so back to it. We've added the chitinous exoskeleton, and so now we're getting back into some other organisms. So we have the starfish and the human, and so this ends up being a little bit different. The starfish and the human have a single character that they have in common that nobody else on this particular chart has. And that is that their anus develops before their head does. So I'm just going to place that here on our basal line. And so now, again, we see that the starfish and the human have this. Now, I arbitrarily put them in this order. I didn't have to. I could flip-flop it. I could turn that around so the human is in the starfish position and the starfish is in the human position. It's not like it's in order of time or anything like that. We're just talking about characters. And since they both share these characters, we don't have to add anything else. It doesn't matter which order those are in. But now we have two more characters that they don't share. So the first one is that the starfish has a water vascular system. So again, that's something the humans don't share. So it needs to be up on that line so that it says that only the starfish has that. And the last one, humans are vertebrates, which is not true of anything else on this particular chart. And so I'm going to add that in here. Okay, so this one was a little bit more complicated than some of the previous cladograms that we've looked at, but hopefully you're seeing that adds to your understanding, and you can see how we can use these charts in order to determine what the relationships are between some of these different organisms. All right, so at each location where you have a connection, so where the starfish and the human meet, that would imply that the starfish and the human share a common ancestor more recently than the fruit fly, earthworm, and snail share a common ancestor with the human. Okay, so if they're closer to each other on here, that would imply they share a common ancestor more recently. Likewise, the fruit fly and the earthworm, they would likely share a common ancestor more recently than the fruit fly, earthworm, and snail shared a common ancestor. Although they did share a common ancestor, but that common ancestor was shared more recently than they would have shared one with the flatworm. So that's what all of those little nodes mean, those little connectors. So it looks very much like those other evolutionary phylogenetic trees that we've taken a look at. So I'll stop there. If you have additional questions, please let me know. I have additional practice on Canvas if you would like to take a look at those. Otherwise, I hope that helped. And as always, stay curious and seek truth.